Welcome back, ladies and gentlemen. In this video, we are going to continue our vector discussion, specifically with the concept of unit vectors. A unit vector is simply a vector that has a length of 1, hence why we call it a unit. It represents 1 unit of measure. As long, of course, as it's not the 0 vector, which of course is a component of 0, 0. Okay? If we do in fact have a unit vector, a length of 1, what will be true is this concept right here, that the unit vector should always equal the direction vector divided by its absolute value or its magnitude, okay? So that's what that V represents. It represents the direction vector. And so what we will be able to do is to find a unit vector for a direction vector. Let me say that one more time. We're going to be able to find a unit vector for a direction vector, okay? The reason why is because unit vectors provide a way to represent the direction of any non-zero vector. They show us a way to represent direction of non-zero vectors. And then, of course, any vector in the direction of this case, V, or in an opposite direction, is going to be that scalar multiple of this unit vector, okay? So really using these unit vectors will provide us information about the direction vector and allow us to identify scalar multiples of the unit vector. So find a unit vector in the direction of -3, 2, and verify that it has a length of 1. And so first and foremost, let's go ahead and find out what that magnitude is. Because remember, the unit vector will equal our vector, our direction vector, over its magnitude. So if that's the case here, the magnitude of our direction vector would end up being square root of -3 squared plus 2 squared, which would equal the square root of 13. And so our unit vector will then now kind of provide us our V over the magnitude. And so let's go ahead and take a look. We end up having U is equal to 3, 2 over the square root of 13. And I'm going to separate this to show you that 1 over the square root of 13 is just a scalar multiple, okay? 1 over the square root of 13 is a number. It is a scalar, okay? So that means if this is the case, our unit vector would end up being -3 over the square root of 13 and 2 over the square root of 13. Now, what we can always do to verify that this is the unit vector is that we can go ahead and show that this vector that we just found has a magnitude of +1. So let's go ahead and just find our magnitude of U. So what we're going to have here is the absolute value of -3 over square root of 13, 2 over square root of 13, and we have the square root of -3 over 13 squared plus 2 over the square root of 13 squared. So this is going to be a +9 over 13. That should be a square root of 13. So it's over 13 because square root and square root will cancel out. Plus 2 times 2 is 4. Square root of 13 times square root of 13 will cancel out. And so we do get the square root of 13 over 13, which is a +1. That confirms it's a unit vector. Let me back up, recap what this video was all about. Unit vector has a magnitude of 1. We can utilize it to show a scalar multiple of a certain vector. And so if you kind of think of what we just did here, is we found the magnitude of, so we did in our first step, we found the magnitude of the original direction vector. From that point, we always know that the unit vector will be the direction vector divided by its magnitude. and this provided a scalar multiple. At that point, we found the unit vector and then confirmed that it did have a magnitude of 1.